Every year, farms and fields play host to a symphony of sorts. Pollination, the springtime syncopation of flowering plants and the animals who feast on the nectar and pollen they produce. Over millennia, pollinators like honeybees have evolved a well-timed dance with plants. But now, plants may be changing their tune. Spring green-up, when plants wake from winter and sprout leaves. It's such a global phenomenon that NASA satellites can see it from space. Sensors, such as MODIS on NASA's Aqua and Terra satellites, can show us how green our planet is throughout the year, and they've captured something strange. In the northern US, spring green-up is starting about a half day earlier each year. The likely cause? Our warming climate. But is pollination also moving earlier? The images can't detect individual flowers, so scientists have been left to guess, until now. NASA research scientist Wayne Esaias spearheads a special team gathering data directly in the field. They're the honeybees in his Maryland backyard.
Honeybees are great data collectors for understanding processes of pollination. Bees fly 2.5 miles in all directions to scout for bee forage and bring back pollen and nectar. And so therefore they sample a very large range of environments.
By weighing the hives, Wayne can detect when nectar peaks and ebbs each year.
During the winter, the hive loses weight as they eat the honey to feed their babies and keep warm. And then when plants start blooming in abundance, the hive starts gaining weight. It can gain a tremendous amount of weight. I've had a hive gain 25 pounds in one day.
Wayne's been keeping tabs on his bees for less than 20 years, but in that time, pollination has moved more than 10 days earlier.
That's completely in sync with what the satellite data record shows, the world here getting greener earlier in the spring by about a half a day a year. If we have a few scale hive measurements with the wall-to-wall coverage of the satellite, we can then extrapolate those scale hive measurements of when the nectar flows occur to very large areas of the country.
Now, to get a bee's eye perspective of how pollination is changing in very different environments, say deserts or mountains, Wayne's doing a little networking.
Honeybee Net is a network of citizen scientist beekeepers that volunteered to weigh their hives to give us more data points, to see how the nectar flows are changing in all different parts of the country.
If pollination dates keep creeping forward, plants and pollinators could move out of sync. Currently, young bees are able to grow and get out on the hunt by the time plants bloom. But if plants bloom before bees are ready, both miss out. The plants don't get pollinated and the bees go hungry. But more than just bees might miss a meal. NASA satellites can help us understand how climate change might affect what's on our dinner table.
Modern agriculture requires bees as part of the production. It's as mandatory for food production as is pieces of irrigation pipe and fuel for tractors. So if we're to understand the impact of climate change on our ecosystems, we must understand how this plant-pollinator interaction is being impacted by climate change.